everyone. We are going to start looking at Chapter 8, Section 2. We're going to talk about quadratic functions in vertex form. The first graph that I have right here is just the parent function, which is f of x is equal to x squared. And so I just went ahead and graphed that. What we're going to start looking at now is when we're going to be moving the graph just like we've done before. With absolute value and with lines. So in looking at this, if I have a function, we'll call it g of x, and this time I am adding a number onto, sorry, my Norton keeps doing that, x squared, and I add a number, let's say plus 2 on here. We're going to talk about how does that affect what happens to the function and to the graph when we do that. And so if you were to take a guess and you remembered what we did before, you might say it's going to move up 2. And let's go ahead and see what happens. If I put in 0 for x, I have 0 plus 2 is 2, and that's exactly what happens. When I put in 1, I would get 1 plus 2, which is 3. And so this point, all of these points end up moving up 2. When I put in 2, I get 2 times 2 is 4, plus 2 is 6. So this is 4, 5, 6. And so the graph would look like, my graph was not very good when I drew the lines in. So it looks up here. Everything has moved up 2 points. So when I am adding something at the end, it is going to move it up 2. Which then we also need to look at, let's say I had h of x is equal to x squared minus 4. And what happens when I do that? I put in 0 and subtract 4. 1, 2, 3, 4. When I put in 1 and I subtract 4, I get negative 3. If I put in negative 1, I get negative 3, and so on. And so what happens here is it goes down 4. Every point goes down 4. So this would be at the point 0, or 4, 2, 0, and this would be negative 2, 0. And so this is what the graph would look like. And so we're finding, just like when we did other graphs, when we are adding something at the end, if it is positive, it is going up that amount, and if it is negative, it is going back down that amount. If I'm starting out with, we'll see how you do here. If I'm starting out with f of x is equal to x squared, and then I say g of x is equal to x squared plus 3, how does the graph compare? And then hopefully you would say g of x is moving up 3. If I had h of x is equal to x squared minus 2, you would say the graph is moving down 2. Okay? And so the way they're notating this is g of x, if this is our parent function, f of x is equal to x squared. This is going to be x squared plus, they're using the letter k. Okay? And so k is what's determining whether it's moving up or down. The next transformation we're going to look at is going to be when we take the parent function, and this time we add something that is inside of the parenthesis, which means before we square it. Okay, so again, if we were to graph this, and also if we were to think about what happened before, what do you think would happen? And remember, this is the one when it moves, it is going to move right or left, and this is the one that is the opposite of what our mind wants us to tell us. We see this negative sign, and for some reason we want to say left, but it does go to the right. And we're going to see how by graphing, how that happens. If I put in 0 here, I get 0 minus 3, which is negative 3. But when we square it, we get 9. And so we would have the point Okay, Sorry about that. My husband is in a meeting too, and he just interrupted me. He was loud, so I lost my train of thought. Okay, so we're subtracting 3. And when I said when you put in 0, you get negative 3, and you square it, which is 9. So when I'm graphing the point 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, see what just happened? This point moved 1, 2, 3 over here to the right. When I put in 1, I get negative 2 squared, which is 4. 1, 2, 3, 4. Again, this point moved over 3. So where's my vertex going to be? My vertex is going to be right here at the point 0, 3. And then I could just plot in points, or I could just move every point over 3 that I already had from the parent function. And then this is what my graph looks like. Okay? So what we're doing when we see something like this, if we can recognize it without graphing, and again, I've said this before, if you forget things, like if a couple years go down the road, you can always graph it and see what happens, and to trigger your memory. But what this is telling me is when I'm looking at this vertex, the vertex here is going to be, normally it would be at 0, 0, but since here it's moving 3 to the right, it's going to be the point 0, 3, if I were asking you where the vertex is. So this is moving 3 to the right. If this were a positive number in here, if I had, again, we're starting with f of x is equal to x squared. If I had h of x is equal to x plus 1 quantity squared, we're adding 1 in here. What do you think is going to happen? It's going to move 1 to the left. If I had j of x is equal to x minus 5 quantity squared, it is going to move 5 to the right. So I need to add then, when we're talking about the vertex now, if I see like this x minus 5, the vertex on this is going to be 5, 0, because it's moving to the right. This one would be negative 1, 0, the x plus 1. Okay? Since we're talking about this section is the vertex form of a quadratic function, this is what it actually looks like. We have f of x is equal to x minus h quantity squared plus k. And so when you're looking at this, we plug in the numbers, it's going to tell us what the vertex is just by looking at it. So you wouldn't have to do any graphing and figuring it out. And the way you remember this is that, remember when we add something on the end, that's what's moving it up or down. When we add this in here, that's what's moving it right or left. So this is going to be your x value, and this would be your y value of your vertex. For example, if I had f of x is equal to x minus 1 quantity squared minus 3. If we were to explain this, we would say, okay, well, this is telling me it's moving to the right 1, and this is telling me it's moving down 3. And so that would give us a vertex of 1, negative 3. It has to be in this form in order for you to do that. And you could always graph points and you would be able to figure this out. But this is just telling us how we can look at something and we can easily tell where the vertex is. If I had f of x is equal to x minus 1 quantity squared plus 2, this means it's moving right 1 up 2. It's going to have a vertex of 1, 2. Let's do one more. F of x is equal to x plus 2 quantity squared minus 1. This is telling us that it is moving left 2. And when I say left 2, it's starting at 0, 0, because in our parent function, that's where it was 0, 0, and then down 1, so it would be the point negative 2, negative 1. And that just means if I were graphing it, this is where my vertex would be. And then everything else would be the same. Okay? Plugging it in wise. When we talk about your axis of symmetry always goes through the vertex. And so that's going to be whatever this value is here, is your axis of symmetry. Again, it's a vertical line, so it's going to be x equals. So your axis of symmetry would be at x equals -2. Your axis of symmetry here would be x equals 1. X equals 1 for this one up here. So whatever h is, that's where your axis of symmetry is. For this, the rest of this example, I'm going to go ahead and use the book just so that I don't have to do all of this graphing. I'm on page 324 of your book. What is happening now, we are talking about, and it's confusing when you look at all of this. This is in vertex form. If you see the x minus h quantity squared plus k. So again, this is if it's moving right or left. This is moving up or down. And now we're putting an a in front of it, which means we are multiplying by a number. And remember what we talked about in the last section. If the number was bigger than 1, it is going to get skinnier. If it is a fraction, meaning between 0 and 1, it is going to get fatter or lay flatter. And if that is negative, that's when it flips it upside down. Those are the 3 things that we walked away with from the first section. So when I start out with this right here, and this is graphing in vertex form, we can see here I would have a vertex of 1, -3, which that's the exact same point that is. And then I would graph it. When I graph this one, I still have a vertex of 1, -3. But when I multiply it by 2, see how it gets skinnier or steeper? The blue one is in the inside of it. On this one, I look here and right away I can see I have a vertex of 1, 2. That's exactly where that is on both of them. But this time I multiplied by a fraction, a number between 0 and 1, and see how the blue one, it flattened out a bit. It is flatter, it is wider. On the last one, what happened here is we multiplied, we have a vertex of -2, -1, which is right here. And we multiplied by a fraction, which made it wider, which it did, but it's also negative, and that's why this one is flipped upside down. So if you can remember those things, that is exactly, you can tell what a graph has done from the parent function. And here down here they list it, f of x is equal to a times x minus h quantity squared plus k. That part in itself is confusing, but if you understand, you remember, okay, this is going to be my axis of symmetry. This is also going to, this is if it moves to the right or left. This is up or down, and when I multiply it outside of the parenthesis, that's what's going to make it either steeper or flatter. When I look under the triad right here, how does the graph f of x equal -3 times the quantity x minus 5 squared plus 7 compared to the graph of the parent function? Well, we have a vertex of 5 is 7. That means it's moved 5 to the right and up 7. It is flipped upside down because this is negative, and then it is steeper or skinnier because it's multiplying by 3. I'm going to go ahead and end this video and finish the rest of the examples on another video.